this thing. Which way are you going? My name is Matt File. I'm the co-founder of DataStax. This is Rick Branson, the
you can have the extra.
that's right. You do need the extra, right? The infrastructure engineer for Instagram, and Adrian Cockcraft, which I don't know your official title.
Something.
Cloud something at Netflix. At some point it was architect. Right?
Yeah.
So first of all, there's only one mic and it's mounted to that, so we're not using it. So if you guys can't hear us in the back, raise your hand and we'll scream at you louder. I know you, don't even try that. The purpose of this talk today came out of a conversation that Rick and I had at one point, which was we were debating the money effects of strong consistency versus eventual consistency. And so we're going to discuss that because it's the intersection between how technology and the business actually really collide, and you actually want to do different things on the business side versus you've ever thought of before because the technology enables them for the first time. So to really kick that off, at a high level, the old world around strong consistency versus eventual consistency is strong consistency in layman's terms, and guys, jump in whenever you want me to stop talking, you have a master and slave architecture, right? And in general, and you always knew if you put something in, you got that thing back. But there's some really strong limitations to that because the world's becoming global. You have things like downtime actually happen, and eventual consistency can solve some of those. So first of all, I gave my definition of strong versus eventual consistency.
No, I think that was really good. I think that people tend to think that the choice there is something that is sort of binary in a way, where it's like you're either weak or you're strong. It's really more of a spectrum. And actually, eventual consistency isn't technically a consistency model. It just means that it's a way to describe a system like Cassandra or like Dynamo or React, these sort of Dynamo-based systems. And I think, kind of to Matt's point, the idea is that it opens up this new area of actually thinking about, how your latency and your availability kind of impact your business decisions, and actually starting to work with your business people instead of having this one-way street where they say, it has to be strong, that's the way it is, and how the business can actually be informed by and work with the technical side on these consistency issues. I think people that are going to be sort of making these relationships work are going to be able to use these systems to their fullest and actually get a business advantage from this stuff. Does that make sense, or is that crazy?
So I guess my attitude is you never really had strong consistency in the first place. If you have one perfect database, then maybe you do, but everyone has more than one database, and databases aren't perfect. So you end up having to do some kind of consistency check at some point anyway. If you're building, anytime you have queues between things, or you're storing data in more than one place, it's not consistent.
Yeah, as soon as you have memcache, as soon as you have, even if you have two databases, you're storing your data of two different types. If you're doing that one, if you're writing them from a single sort of user action, you lose your sort of cross.
As soon as you get a client device involved,
right.
The client device is only weakly consistent with what the database is doing.
I have a joke that I actually think, Instagram, obviously we work with a lot of iOS developers, that most iOS developers probably know more about consistency than the average web developer because they're separated by this network, and not only a network, but a mobile carrier network, which is usually terrible. So they've had to learn to kind of deal with those gaps and treat that as a distributed system. So.
If you abstract to even like the functional use case, very few things in the world are actually strongly consistent. Like everyone says, oh, banks, strongly consistent. If you have a checking account, you've probably overdrafted your checking account at some point, and the world did not end, right? You got a fee, and they fixed it after the fact. It's eventually consistent. It doesn't matter. The only thing where this actually really started was the one thing that you can't overdraft successfully is a gift card because they don't know who has it. In which case, hence the title, it's an actuarial decision where you just go work backwards to the price of your product and increase it by the percentage needed to cover the lost whatever. But that's not just gift cards, that could also be stolen product, etc. So there are actually very, very few things in life that actually have to be strongly consistent. I actually don't know that.
Yeah, so I think
that's a good paper by Eric Brewer at QCon last year, where he was basically explaining how ATMs are weakly consistent, and it was basically another look at the gap theory for that.
That goes back to the whole like bringing your business people and getting them involved in these discussions. Because like, for instance, the whole like gift card thing. Like, I think a better example that generalizes a little bit better is what happens if your inventory counts are wrong. Like so you can have like here's real world. You dropped your hidden handoff because somebody actually literally physically dropped the device that they were using to scan things in the warehouse, and they lost that data. So then now you've actually, that inventory is, you've lost track of some of your inventory, and you then try to ship that inventory and it doesn't exist. You've already told the customer you were going to ship it. So what do you do at that point? A lot of people will do things like, oh, we'll just give them a $10 gift card. Obviously things like that happen across the board. Just because your database, you see it as this sort of very clean thing, doesn't always mean that that's the reality. And then you can kind of extract some of these concepts from sort of the real world, like what happens if the inventory counts are wrong, and apply that to database.
That they are wrong.
Yeah,
inventory counts
sure.
are always wrong. I was trying to buy a 10 of something at Ace Hardware, and the local store had 2 of them. So I got to look up all the local Ace Hardwares to see how many they had in stock, and then to like rove around attempting to buy my total of 10. And they told me how many each one said it had in stock, and they were completely wrong. One of them had 20 notes, they had 3. And so I just went, the reality inventory is never up to date anyway. So, but the thing is really about what's the cost of being wrong. And the thing about it from a software developer's point of view is the things they not want to have to deal with. So they don't have to deal with the fact that it might be wrong. So they want to pretend that it's consistent because they can have a model in their software which pretends it's consistent. Then they don't have to worry about it. And every now and again it'll fail because of something, the reality doesn't conform to their model. But they can write software that's simpler. So I think that's really what we're looking at, is how simple is it for a software developer to deal with this world that isn't quite consistent. And the better the abstractions and the better the patterns that they're used to, the more patterns they get used to, then they get more comfortable with it. And I think that what Cassandra's doing, what the NoSQL movement's doing, is it's popularizing and people getting their heads around it, and it's become less of a, don't go there, it's scary, and something was, we know how to deal with that.
I think there's a lot of great research out there now that's getting inspired. We talked about Peter Bayless and some of the work that he's doing with trying to understand exactly what, if you can bound all of these things and kind of contain all of these variables and predict them, that obviously helps. We talked about actuarial decision, actually nailing down, okay, maybe it's going to cost us this much, and compare that to what basically be able to compare and contrast your risks for things that are inconsistent or slower or faster or any sort of impact, because consistency is a little bit tangled with the whole latency. If you have to read from 2 replicas on the forum, it means you will have higher latency than if you have to read it from 1 node. So I know that we were going to get into that. So.
Yeah, why don't we sort of jump there? We said how eventually consistent systems are actually good for the business. Well, let's work that back to the technology side. And when you accept an eventually consistent system, because it is anyways, there are some very blatant, obvious technology things, whether it's around availability of the system. In other words, it's very hard to do business if the system isn't working, all the way through to performance due to things like speed of light. You guys want to jump in on either one, or you want me to keep going for a little bit?
Yeah, I think it's a pretty well-known thing that sites and software and products that are faster are more accepted by the users and are generally more profitable. I think that's a pretty well-understood thing at this point.
Yeah, there's 2 very public studies on this actually that I reference way too much. Amazon found for every 100 milliseconds of latency they introduced into the search experience, they lost 1% of revenue. So 100 milliseconds, 1% of revenue. And Google found that for every 500 milliseconds of latency they introduced into search results, they lost 20% of traffic. So being slow is exponentially bad.
Is it clear to everybody why the consistency and latency are intertwined? I don't want to.
And this is pretty informal if you notice we're streaming into a room with no microphones. So if you have questions, just raise your hand real quick. We already have a few minutes at the end.
Okay, I got it.
Go ahead.
You guys obviously consider for a lot of things. Do you expect any community for using eventual consistency? I flew down here and I was thinking, I never saw any issue using eventual consistency in my life. But when I tried down there, like flight status, like 5 6 data, if the train location is like not eventually consistent, like you see mid-air pollution, those kind of things will happen.
Yeah, that would be terrible. because
That
we
would be
don't want
terrible,
that-
I mean,
yes,
when you
yeah.
know, there are two trains colliding with each other, you've got to make sure the location of the train is
Sure.
correct, right?
Sure, but at the same,
The airport is eventually consistent, 'cause that's never accurate.
What's that?
Which gate you go to in the airport is eventually consistent.
Yeah,
That's never
that's not a problem,
But-
because you don't care about that.
Right,
but-
but it's also, it's one of those things where it depends on who's reading it as well. You know, your flightstats.com doesn't have to be
Yeah.
as accurate as what the people in the,
Yeah, they use it.
in
You've
the,
got bounding box, I mean, aircraft position, they build lanes of bounding boxes and put lots of space in there. So they make sure that it doesn't need to be, even if everything fails and the entire flight system, if every plane keeps flying along its current path, then they shouldn't hit anyway. So the actual system is not dependent, right? Safety shouldn't be dependent upon a particular database being accurately up to date for planes not to crash into each other. Right? So occasionally they do get completely off into the wrong part of the airspace or whatever, but they're generally set up to be flight safe.
everybody,
Planning
you know,
plans.
calm down, don't get too afraid on your flight home.
Maybe
Yeah,
You have to do that.
they're either drift into failure, but
And actually, to even emphasize that, flight stats, for example, is eventually consistent because everything's relayed by FIDOs for security purposes. It is. You don't have accurate flight information. So on one side, performance matters, and one of the real benefits around any eventually consistent system, whether it's Cassandra or any time you set up, for example, like my SQL replication back in the day, which was asynchronous, you span data centers sometimes because that SE speed of light thing is really hard to go faster than, right? So if 100 milliseconds is a magical number to be quicker than, it's hard to do that if you have one data center and you're traversing the world. Speed of light between the coasts is like, what, 40 milliseconds?
yeah, we got 84 milliseconds round trip from US East to US West.
That's over network too, so that's pretty good. So
Yeah,
if 100
that's round trip, so.
Okay. Yeah, so round trip from coast to coast was 84 milliseconds. You're almost at the 100 milliseconds without even doing anything to the data at that point, right? And that's just you making the call. So having data centers located around close to your user actually really, are the only way to really help out with speed.
And so we did some testing where we tried to cut the startup latency for our applications on Netflix. And the Netflix is a little different because you already pay for it. So it's not like an advertising site where if you get slightly unhappy, you go to try a different advertising site and you click away. You've already paid for it, you're trying to get the movie to start. And we optimized the startup time for Brazil by locating some machines, basically firing up some machines in AWS and Sao Paulo. And we cut a second or two off of the startup time for playing a movie. But it only affected, it turns out most of Latin America route through Miami to get to anywhere. So the network is not what you'd think it would be. The network is a big star from Miami, and the fact that we optimized a little bit of it in Brazil, it turned out not only all the ISPs in Brazil go to Amazon Brazil directly, most of them do, but some of them went via Miami to get to Amazon Brazil. So it turns out, we were able to use, it's the cloud agility thing, we were able to fire up, if anyone's ever tried to buy hardware in Brazil, it's next to impossible. But, in 10 minutes,
as indicated by these two
I can have a
prices.
Cassandra cluster in Brazil, and it's the same time it takes me to do it anywhere else in the world. Let's talk about it. We didn't actually start with, I think we did actually start with Cassandra cluster out there, but we, one of them. So we basically set up enough infrastructure to test this, and then we decided after a week or two of testing it didn't work out, shut it down. And that's part of the infrastructure agility that lets us try stuff, learn something, and this sort of OODA loop of learning, or orienting ourselves, making decisions, and being able to decide things and learn about infrastructure and deployments and all these things faster than our competition, who are struggling with still trying to argue with IT about whether they could even have a data center somewhere in Brazil anyway, and how much it costs to ship things there, and we've just fired it up. But before you even had the conversation, we've already completed the experiment. So that's the thing for us that saves money, the ability to learn really quickly and in very small incremental ways and get out of and it's all about agility rather than cost. Is that how? Because the longest pole in getting something done now is developer time. And anything you can do to reduce developer time means that you're more competitive. And that means that you generally make more money. It means you've got more money to spend on developers. And if you start worrying about cost reduction, what you're actually doing is slowing down your developers. Usually it makes you less competitive, then you have less revenue, and then you do cost reduction again. You get into that sort of enterprise death spiral kind of, a bunch of companies you could probably name that are stuck in that spiral. We're always trying to drive it the opposite direction, speed everything up, and that means you end up having more money, and then cost becomes less and less of an issue because you're getting more profitable as you speed up.
One of the questions, and what we're going to do for about 5 more minutes, then open up for just full-fledged questions. Although she's saying 5 minutes, do we not have till 30 after?
Yeah, so you have 5 to 7
Okay.
minutes to talk and then another 3
Okay,
minutes
she's
for
on purpose.
questions. I'm on purpose.
One of the questions I hear all the time is, when do you go from the cloud or Amazon to your own data center? And we're lucky we have someone from Netflix here. And in terms of tale of two different companies, I use this example all the time, is you guys who are very committed to the cloud versus someone like Zynga, who started Amazon and moved off of it. Language terms, you guys both went through a period of business where it was a little shaky. You guys just spun down servers, if I'm correct. Zynga,
We actually went and tuned our code and halved our bill.
look at that.
There was all this fat in the system. We're going to be marginally profitable next quarter. Okay, every million accounts. Let's go tune our stuff up. And we actually, we were basically just throwing hardware at getting things done faster. We were actually going from a phase where we were full on just porting to the cloud and getting stuff to work at all and getting it reliable. And then we went, let's tune it up. And we took our cost trajectory and we just flatlined for quite a long time, but we were actually growing the business on a flat capacity for a substantial period by optimizing a lot of stuff out that we hadn't previously worried about. And that meant that we could control our costs down and be very agile. Like, we could have committed to building a data center somewhere in Europe and then decided not to go to Europe, right? Because, given the business sort of getting shaky in one particular quarter. But you're already committed because data centers take 6 months to build it for Google or Amazon, and sort of 9 months to a year or more if you're a mere mortal kind of company that does it normally, right? But Google and Amazon, they're incredibly good at building data centers, and they're doing it incredibly fast in 6 months, right? Most people way longer than that. So you're committing early, and that early commitment is longer than our window into the future for making business decisions about which country we want to be in. We want to choose which country we're going to go into less than 6 months before we go into it. And then we say, okay, we need machines here, let's just go do it.
And your quote on Twitter, I think it was your Thursday or Friday last week, was someone actually asked him, why are you guys in your data center? And he's like, I love your quote, I'd rather put $100 million into a new TV series or a new country rather than the data center. And his point about growth mode, when you are in that hyper growth mode, you want to put all your money into the growth, not the cost optimization aspect of it.
So we're cost optimizing our old DVD business, which is slowly shrinking, and that we're just trying to run that as efficiently as possible, right? And there's no new features there, there's no new customers coming in, people are gradually switching to streaming. And that business is just a slowly shrinking, mature business. It still runs on Oracle, it's still in the data center. We don't even know how to modify the schema on that database anymore. I don't think we have anyone left that actually remembers how it's supposed to work. So we're kind of tweaking it around the edges and trying not to break it, while cost reducing everything around it. Right? So that's the business model of a mature business. And within Netflix, there's one mature business where we're just sucking profits out of it to fund expansion everywhere else, and one fast-growing business where we're sinking money into new countries to invest in the future.
Yeah, I think that to kind of bring it back around to Cassandra, all of this is sort of, the point of all of this is that if you want to take advantage of these types of things, you have to be on, really you need to be on a platform that is cloud native, to borrow Adrian's term. Is it your term? I'm going to give him credit for it. So, to borrow Adrian's term, and of course,
Shadow Cloud 2.0, everyone hates the 2.0.
oh, that's terrible. Please, no. No more 2.0s. Because that means there's a 3.0.
Yeah.
So the idea is that, Cassandra is, deals with some of the rough spots. I think you talked about the fact that, you're sort of building this system on top of this somewhat unreliable, somewhat ephemeral system. And sort of kind of bring all that around, and that's what we're all here talking about is enabling through this technology. So
yeah, we talked about scale just before we came in. Right now, the scale at which the cloud stops being usable is about 100,000 machines, sort of somewhere in that range. If you've got more than 100,000 machines, you really need to be running your own cloud. Most of the, Facebook's bigger than that, Google's bigger than that. A lot of the banks are bigger than that, the really big banks, the top 4 banks. So they're running their own stuff, and they should be running their own stuff. They've got enough money and enough people to do that. But if you're in the sort of 10,000 to 100,000 range, it's kind of optional. You can choose to do your own, or you can choose, I mean, Netflix is in a few tens of thousands scale. And the other thing is that that range is going up. You could argue it's going up by about doubling every year, because Amazon's roughly doubling in size every year. So the size of the public cloud, if it just keeps doubling, then we're kind of good to go, because we're not growing quite that fast, and we're going to stay in that sweet spot. I mean, there are times where we have outgrown our ability to deploy stuff. And come back to the Cassandra point of this, we've got an architecture which I can see trivially will work at sort of 3 times our current capacity. We currently have 36 million customers. To do 100 million customers is kind of like, yeah, so just auto scale up. There might be a couple of tweaks around the edges. If we wanted to do 10 times my current number of customers, we'd probably learn something they didn't know about our architecture, because every order of magnitude you do that. But ultimately, you know, we have Cassandra clusters up to 144 nodes right now, and it's just linear. We can see that going, and we can see getting more out of each node as well. So it's really fundamental to a scalable architecture to have a data store that you can just throw things at. And that benchmark I ran 2 years ago now, 288 nodes, and it was linear. It's okay, we're not going to need that for a while. So 2 years later, we haven't quite hit that. We're still at half that scale. We're running more performance than that per node, but the scalability is still there. That is really the most fundamental thing about Cassandra. That and the ability to do global distribution are the 2 killer features that really needed to have anybody in Netflix, okay, we're going to do this next, and go, yeah, so whatever. It doesn't matter from an infrastructure point of view what the business decides to do.
So we got the sign in the back that said wrap up, so.
So we have time for 3 questions.
3 questions.
3 questions, choose them wisely.
Number 1,
One of the questions is about maintenance and operations. You talk about scalability in terms of release, management, downtime, maintenance. How does it come in terms of eventual consistency?
Well, I think the replication helps. So the question is around maintenance and how do we do that. You've got a distributed system with replicas in it, and we use Jenkins jobs that rotate through our cluster, and at any point in time we're replacing a node in a cluster. I mean, continuously. We go through every machine. We've got 1,000 machines, and once we get through replacing those 1,000 machines, we pick a new version of Cassandra, go to our test environment, and we systematically replace every Cassandra instance in our test environment with a new version of Cassandra. And once we get to the end of our test environment, we go to production, and we do that again. We've been running that pattern for 1.5 years, 2 years now. That's the way we do it. So there's always a machine in the middle of being upgraded, but it's one instance out of 6 to over 100 nodes per cluster. So it's basically the way that the fact that you're using triple replication means that I can take a node offline and still have a quorum succeed. That's the key thing. That's why you don't use the all thing, because you're always going to take something down, and you're going to do write all or read all. You're going to
it definitely really changes the whole way that you view doing maintenance. So you just do it like there's no. It's this whole agility thing. You just don't wait. You just.
Yeah, DVD still goes down for 10 minutes every 2 weeks for Oracle schema to get updated with the new push. Because it used to be 2 hours. We got down to 10 minutes, but you still have to bounce Oracle.
all right, next one.
A question about replication. You said you're doing replication of whole regions in your other talk. Did you mean Cassandra replication, or are you replicating at more of a different level than that, where you're building your own replication job?
We're using Cassandra to replicate all the data that we need in a region to another region. So what we're trying to do is get to a point where Netflix USA runs out of the US East and US West regions, and we can send traffic to either one, and all your data will be there. And within 100 milliseconds roughly of latency, it's consistent across both of those. And we're asynchronously replicating. So you'll be able to, we'll be able to switch the traffic from one to the other, shut down an entire region, or have a failure that takes out a whole region. And our customers, our goal is to have no additional CS calls, right? That's our measure of uptime.
My question was about the economics of sort of scaling with Cassandra over time. Obviously, you talked about making your own data center versus leveraging Amazon's or someone else's. The question I had was, I assume at some point you've changed the size of the Cassandra machines and upgraded, and we're going to run them on extra larges instead of larges going forward. How do you sort of make the economic determination when it's more valuable to start putting better hardware in place, on nodes that are all functioning versus just adding more nodes to the cluster. So scaling up versus out.
I would say that most of my experience with on EC2 has always been that we use the largest nodes of any given type. So we basically use 3 different types of nodes. We use, and really just 2 now. We use like M1 extra large, which are two core really, 15 gigs of RAM, and they just got a big terabyte and a half of just big disks. We use that for like data warehouse type storage. And then we use the H1 for storage instances, which are SSD based. There's a lot of good reasons, and these are really get down to EC2 specifics around like using the higher class nodes. As far as Cassandra's concerned, I mean, I would never make a trade-off between like hardware size and, I mean, I would always go for the sweet spot in terms of price performance for the given node, and then just go from there.
There's one additional thing, which is how much data you're storing per node, and you might want to go horizontal, so that if you lose a node, what's the time it takes to replace that node? So how fast can you stream data in? But what happens on the high one 4x large is on a 10 gigabit network, so they actually stream data in more quickly as well. So you can put more data on them, and you can run fewer of them. So this was my sort of benchmark from last year, which we took a 48 nodes M2 4XL cluster and replaced it with a 15 node SSD cluster. So obviously we had 3 times as much data per node, but we're able to manage that partly because of the extra network bandwidth. So there's sort of a few trade-offs there that you might want to take into account. Typically we're running on the SSD ones now. Previously we've run almost everything in production on M2 4XL, the 68 gigabyte ones, because there wasn't enough disk anyway, so we tried to keep everything in memory.
Yeah, that's going to be totally specific to your environment, basically, like what the hardware.
And we're getting waved out, so what we're gonna do is we're gonna head outside so the next one can get in here, and if you guys have questions, come find us.
Thank you guys.
Thank you.
Thanks everyone.